The Ramsay Mechanical Aptitude Test is built around everyday situations you've seen 100 times before. You won't be doing long calculations, dealing with complex machines, or using a calculator. Instead, the test shows you things like doors, shelves, towel bars, wheels, gears, carts, hand tools, and containers of water, and asks you to figure out what's really happening in each scene. The MAT-5 is testing how quickly can you understand the forces, balance, leverage, friction, torque, and basic physics at play, without writing anything down. Let's take a quick look at how the MAT-5 is structured. You get 36 questions and 20 minutes, roughly 30 seconds per question, which means they want to test how quickly you can understand a real-life setup. The MAT-5 officially doesn't separate questions into categories, but clear themes are repeated in the test. These are everyday objects and basic mechanics, workplace equipment and mechanical advantage, basic science in real systems, pressure, motion, friction, hand tools, grip, and practical choices. Now let's get started with everyday objects. Here's our first example from everyday objects, a kitchen cabinet. Now let's solve this one. When you hang a heavy pan on the very edge of the door, you create torque, a twisting force that tries to pull the door downward and outward. That twist affects the two hinges differently. The top hinge gets pulled outward from the frame, putting it under tension. The bottom hinge gets pushed inward toward the frame, putting it under compression. And in real life, hinges handle compression much better than tension. A hinge under tension is the one more likely to loosen, stretch, or fail. So here, the top hinge is carrying the more damaging force, which makes it the one most likely to fail first. That's option A. Now let's look at another example from the everyday objects section. Here, we've got two shelves, and the test wants to know which one is more likely to sag first. Shelf A, the top shelf, is carrying the heavier load, and all that weight is sitting on a right side panel that's already weaker. When a weak support has to hold a heavier load, it bends more, and that bending over time is exactly what causes a shelf to sag. Shelf B has much lighter items, so it doesn't push nearly as hard on that side panel. So in this setup, the shelf under the most stress, the one most likely to sag first, is shelf A. Here's another torque example. Which screw is more likely to fail? When that heavy towel hangs on the far end of the bar, it creates torque, a twisting force that tries to rotate the bracket off the wall. Think of the bottom screw, screw B, as the pivot. The twist pushes the bottom of the bracket into the wall. That's compression. At the same time, it pulls the top of the bracket away from the wall. That's tension. And screws almost always fail under tension, not compression. So the top screw, screw A, is taking the more damaging force and is the one most likely to pull out first. The correct answer is option A. MAT-5 brings in some basic fluid and physics ideas, the same ones most of us learned back in school, but now shown through everyday situations. What they want to test is simple. Do you remember how fluids behave? What actually controls pressure? And how water levels adjust when containers are linked? Let's see how MAT-5 turns these concepts into practical questions. This question tries to trick you into mixing up weight with pressure. Yes, tank A holds more water, so it's definitely heavier to lift. But that has nothing to do with the pressure on the gauge. A good way to think about it is this. If you dive 10 feet deep in a small swimming pool, and then dive 10 feet deep in the middle of the Pacific Ocean, does it feel different? No. The pressure on your ears is the same. That's because pressure depends only on how deep you are, not how wide or how full the container is. So if the gauges sit at the same depth in the same liquid, they read the same pressure, no matter the size or shape of the tank. The correct answer is C. No mechanical aptitude test is complete without gears, belts, and pulleys. You just need to remember the basic connection rule. Meshed gears spin opposite ways, and an odd number of gears means the first and last turn the same way. In this question here, gear A is turning clockwise, and the question asks which way gear C will turn. Here's the simple rule you need to know. When two gears touch directly, they always spin in opposite directions. If gear A turns clockwise, gear B must turn counterclockwise. And if gear B turns counterclockwise, gear C, which is touching B, goes back to clockwise. So the correct answer is gear C turns clockwise. A lot of MAT-5 questions are about surfaces: smooth tiles, rubber mats, metal ramps, textured flooring, and they're really checking whether you notice how that change affects movement. Smooth surfaces let objects roll or slide easily. Rough or rubber surfaces grab onto the wheels or the object and slow everything down. Once you understand how much the surface matters, these questions become easy to crack. This question is really about rolling resistance, how wheels behave on a soft surface. Both carts weigh the same, but the moment they roll onto rubber, the surface pushes back. The wheel presses into the mat and creates a small dip. To move forward, the wheel has to constantly climb out of that dip. Now look at the difference. Small wheels, like cart B, sink deeper and hit a much steeper angle of rubber in front of them. That steep wall slows the wheel down and needs more force to push through. Large wheels, like cart A, spread the weight over a bigger area. They make a shallow dip, so the wheel rolls out of it much more easily. So the cart with the small wheels needs more force to move. Finally, let's talk about the tools section. The MAT-5 isn't asking you to memorize a catalog of equipment. It's testing your mechanical logic. You will see questions asking you to match the right tool to a specific job, or determine which tool offers the best leverage. It essentially comes down to function and fit, knowing which wrench prevents slipping, or identifying which direction to turn a handle to tighten a bolt. If you understand how a tool applies force, you will handle this section easily. The MAT-5 isn't about memorizing formulas. It's about spotting the mechanics, like force and balance, hidden in everyday scenes. Head over to Job Prep Central to practice for free and ensure you are fully prepared.